Good morning, ladies and gentlemen, colleagues, students. You are welcome to the 9th International Conference on Appropriate Technology. This morning, we will be having 6 presentations in all. Just let me introduce myself. I am Professor Patricia Upola from the Tshwane University of Technology. I am your host this morning, and we're going to be having 6 different papers to be presented this morning in this session. This is the first session. And presenters should know that they have 12 minutes to present their paper. We will indicate once you have used 10 minutes, we're going to tell you now you have 2 minutes left. So we'll keep the time. And secondly, we'll take questions from the audience. If they've got any questions or comments, they can actually write it in the chat, which I will read out to the presenter. So use your chat to put forward your questions or your comments as the case may be. So every presenter then will have a total time of 15 minutes, 12 for presentation, 3 for questions and answer. So that is how it goes. We can now start the presentation now. Please start recording. So I call on the first presenter. The title of the work is Appropriate Renewable Energy for Education Infrastructure in Rural South Africa, the Confibaba Science Center Model. Author is Jaco Nice. Can you start presenting your work, please, Mr. Jaco Nice? Dr. Nice, you are muted. Can you start presenting?
Thank you so much. I was speaking to myself.
Yeah.
So I will start speaking to everyone. The discussion this morning will be on the appropriate renewable energy for education infrastructure in rural areas. And we're going to use the Confibaba new science center model that has been produced through support in the from the CSR, or the Council for Scientific and Industrial Research, which is where I am seated, the Department of Science and Technology, or now Science Innovation, and Department of Eastern Cape Education, and the local municipality in Sikayetu. So I think the first point is that we need to start thinking outside the box, especially when we consider rural areas and we consider the dire conditions of our environment, and the appropriate solutions that will address the mass social environment and the mass social people out there. So what I'm going to be discussing is in principle, background, some social economic context, the infrastructure challenges and opportunities in this region, and in large, the South African regions, rural regions. Some innovative technology options that we considered, the applied design strategies, and then the energy generation storage that we are currently busy building and have applied and will be conducting ongoing assessment over the next 5 years. So hopefully in 5 years' time, when we'll have another conference, we can present the outcome and the results, further results and final outcomes. So to give you a bit of context, this is in Confibaba, which is about an hour and a half if you're from South Africa. It's an hour and a half from Queenstown. It's about 2.5 hours from East London, somewhere deep rural in the middle of the Eastern Cape. So the Innovative and tested technologies to improve quality of learning and teaching is what we are applying here at the Kofanwaba School for the Kofanwaba schools in the region. And the big need in the region is in particular science and technology education. And the big challenges that the schools are perceiving is that firstly, there's not enough science equipment or a lack of quality of education. So the concept was developed that a science center with a virtual remote science and technology teaching platform will be developed for both students and educators in the future. The science center is about 1,400 square meters education facility, and then encourages the learners in the district to come either to the facility to directly experience science and the various elements of that, but also to be able to be taught from the center. The center further has to demonstrate and demonstrates green building and green building design, not just in the planning, but also in the construction and the contract processes. And we will now be looking at the way it's occupied and the way it's used. And the building itself, it becomes a living laboratory to test various appropriate technologies for the students, for the greater community, and to understand whether these appropriate technologies that we deem are appropriate at this stage are in fact appropriate for these regions. And only time will tell. But as we know, there are only so many options, so we have to start somewhere. So the Department of Science and Innovation led this campaign to provide public awareness of engagements of science and contribution of to the SET skill set, which is scarce skills, specifically in science and engineering. And this is taking that scarce skill set straight to the communities, in particular the rural communities. It's a great, fantastic opportunity. So the design of the Science Centre uses innovative building technologies, and that's in support of a cabinet and a South African cabinet resolution that was put out in 2013, where IBTs would be used in delivery of some of government's social infrastructure projects in schools and in clinics, and in this case, in the science centres. The science centre is designed to be completely off-grid. It'll be independent of the outside services such as water, energy, and sewer. And also it will be expressing a living laboratory. You'll be actually, the students practically will see how these systems work, and also how the building is constructed and how it was constructed, so that there's a practical understanding for them as they leave the center. And further, they're thinking towards understanding engineering, understanding science and technology innovation. So the Science Center in principle is similar to that of a school, where your large school hall becomes effectively the exhibition space, and that's supported by various classrooms and laboratories that are both chemistry, physics, and computer sciences. It has a multi-purpose center lecture theatre, which is a planetarium, with a adjacent telescope supported through the University of Northwest, which is directly in support of the Square Kilometre Array, or SKA project, led by the DSI. And then the Science Centre will also be intended to be, as I said, a living laboratory where we won't just be able to showcase things, but test them and understand how they work and the efficiency of it. So here's just an idea of what it looks like. The main square area is, if you can see the cursor, is the main exhibition space. The left-hand sides of the various classrooms, and then the planetarium and the center on the top. And you go up one level, you have administrative areas, as well as in the central, you have higher level education spaces, or we call them pods. So, in what is the social economic context in which the center is being positioned? It's in the integrated local municipality. It's one of 4 integrated sustainable rural development strategy area or nodes in the Eastern Cape. It's part of the Chris Hani municipality, which covers about 40,000 square kilometers and has about 840,000 people. Of that, there's about an average family size of 5 people. The majority of these people are school-going age. And the reality of the Kofanwaba region, or at least the Eastern Cape, it has the majority of almost 60% of all students in the country, in South Africa, actually come from the Eastern Cape, which makes supporting the education system absolutely critical. And a building like this and the services it's going to provide becomes fundamental to the growth and development of students. 39% of these populations and these districts are actually below 15 years of age, which makes it critical for the next generation of students. Of that, about 52% are living in poverty. And also that means that the way we use these systems and the systems we apply in these areas or in these rural areas are critical at cost, at longevity, at sustainability, and so on. Furthermore, the local agriculture is regarded as the backbone of this economy, and that is the main economic sectors are community services, which is about 52%. Public sector dominates this region, but however, there's a severe economic low productivity and limited private sector investment and growth. And that is one of the reasons why bringing new technologies, innovative building technologies, to the rural area is as a potential to spark new ways of doing things and creating new sub-economies. And not just with that, but also with the renewable approaches to energy and water and sewer or black water systems. Kofanvaba itself, which is where the town is settled, has the highest population in the district of about 153,000 people, but it also has a heavy burden of HIV and TB as well as other related diseases, unfortunately. In 2016, when we look at infrastructure challenges, majority of the household had used ventilated or improved VIP toilets. About 9% of the households actually only had piped water, and of only that, 35% had piped water inside their houses. Electricity-wise, it's very poor values. Looking at about 11% of the people have lighting in their houses, and 21% don't even have electricity at their places of residence, which means bringing new technologies and innovative technologies, not just for the science center, but showcasing at the science center, making the science practical is just the first step to the greater community. And this data obviously reflects an urgent need for new technologies and new approaches. There's a number of core design factors that were considered, and because of time, I'm not going to go into the details, but we speak about net zero energy and we speak about net zero water. Some of the things that was considered up front was various electrical considerations, photovoltaic panels, hydrogen fuel cells, solar water heaters, and sanitation. We were thinking of bio-toilets, composite toilets, low flush, reed beds. Water, we were thinking about rainwater, sustainable urban drainage, grey water, and so on. And I will get to what we eventually decided and we eventually were able to apply in the building as such. Other considerations were specifically on building, which is IBT systems, heat reflective roofs, attic ventilators, some road surfaces. How do we deal with the stormwater and rainwater? How do we harvest those things? And external lighting, how do we bring natural light into the building, reducing energy, and also including improving solar street lighting so we don't have to take any energy and using it. So achieving a high performance or a green building requires an integrated design and delivery solution. So it considers various models and approaches in order to come to a final solution. And the energy system or the approach that was taken on this building is just one such example. So some of these solutions that was applied specific to this building in order to get the energy consumption down, firstly was the use of IBT technologies, and the way that we used that was using appropriate window walling and systems and lightweight steel structures. I can't get into a lot of detail on that, focusing on the energy perspective, but then also making sure that the way the building was designed to capture the heat gain in the winter and restrict the heat gain in the summer, and in fact, like getting extremely good temperatures in both those seasons. And we will be putting a lot of sensors in this building so we can actually manage and monitor that over the next 5 years as an ongoing project. The entire building is naturally ventilated, so we take away from mechanical systems, which has the potential to not only be of poor health and air quality, but also constantly requires energy and maintenance. So the building is completely naturally ventilated and driven through stack effect processes and so forth. Air tightness, external views, all of these items were considered.
Sorry to interrupt you. You have 2 minutes left.
Thank you very much. Sorry, it's something in my throat. So let's get to the electricity point. Number of items were considered, including photovoltaic panels, wind turbines, hydrogen fuel cells, and solar water heaters, which is all connected to a microgrid system. So this building and just some images of the building, actually is not just a single electrical supply, but we looked at various other systems, and we estimated that those systems use about 110 kilowatt hours per year. Other science centers, this center will combines fuel cells or hydrogen fuel cells, the battery backup systems with PV, solar PV, photovoltaic panels, as well as a wind generation. And then as a backup, we use the national ESCOM line, and then we use further water or solar water heaters to reduce the energy demand. And that is all managed through a microgrid system. The fuel cells uses a proton exchange membrane, and we just got about 80% high fuel energy efficiency. The design of the hybrid microgrid system includes fuel cells, which is not a new system, but bringing all these systems together into an energy approach is what is new. Currently, the energy systems on this project is going to provide us 32 kilowatts of hours of energy per day. And then we've got an ESCOM backup of about 25 kilowatt hours, or effectively 31 kilowatt hours, which we at this point know we are not going to need. For water, we have exactly the same, not energy-wise, but for water, we are running completely off. We've got a borehole connected to the site. We are capturing rainwater to rainwater harvesting. We have got an entire grey water system that is standing free from the main black water system. So effectively, the building is sitting at 100% net water as well. Future plans for the recycling will take us even to an increased level of net zero. In principle, the microgrid controller will be running the PV panels as first point. Second point is going to run through the hydrogen fuel cells, and then third point, the wind turbines. And then as a final backup, we will be doing the ESCOM if required. So in conclusion, the rural built environment South Africa requires appropriate technologies and solutions. And this building or the science center will just start that process towards household delivery also. New innovative approaches deal with old problems, but new educational needs, which is what children need to understand how these systems work, because they are the future. They are the ones who are going to say how we will be using these systems moving forward. They will be the new designers and planners. So we need to get them to understand these systems firsthand at a school level. So I think my time is up. Unfortunately, I won't be able to take you any further to the virtual approaches, but I'll leave you with some photos in the end.
Yes. Wonderful. Thank you for the presentation, Dr. Jaco. That was nice. Let me see if there are questions from the audience. Okay, I have one question for you. Okay, there are no questions.
Yes.
Okay, I don't see any questions. But my take, I just want to understand it. Your innovation on energy actually captures different principles together. I see fuel cell, I see panel, I see solar, I see wind. Do you combine all of them to work as one, or you have separate times? And then let's say in the morning, this is what they'll be using. Once it's 4 o'clock, they switch to this. What is the modus operandi? How will it actually function?
Yes, that's a good question. We are running all the electrical systems simultaneously. So obviously, the various systems will be running. The PVs are obviously not going to be generating any power during the night. But then we have the hydrogen fuel cells, which are converting the air and oxygen, which is an on-site combustion. So we're not going to be supporting or installing any or procuring any hydrogen. We will be creating hydrogen and then converting that into electricity. So all the fuel systems or the energy systems are active at one single time, and it is running through a central microgrid that has been purposely developed for the system that manages the processes and the variable inputs, obviously, because you've got different voltages and amperages coming in. So it's managing that system, and then it is supplying it to the main grid within the building.
Thank you. Wonderful. Have you done the cost analysis of this and probably compare it with all the other various renewable energy systems that are available? I mean, in terms of cost.
So what we are planning to do, and part of the main intention of this system is we are going to do a cost analysis. Obviously, there was an upfront cost analysis at what would be the expenditure of applying these different systems. But now the question is how effectively are we going to be running these systems, and at what cost saving? And that can only be tested in using it. And that can only be tested as we get the occupancy in the building. And that's why we have a 5-year contract actually with the DSI to do the long-term sustainable cost feedback.
But to conclude on the cost, you know, there are certain systems that they are very expensive to probably procure or to set up or whatever. But when they are in use, actually they are more durable. I mean, the cost over a long period of time, it becomes, you know, very cost effective. But there are some that when you procure them or setting them up, they're actually very cheap to set up. But to run it over a long period of time, then it becomes highly, highly expensive. Which side
Yes.
for?
So we went for the higher end items. So we didn't go for your cheap level equipment, and we did a cost variation and a cost analysis on that in order to understand what that was going to be. So that is unfortunately I'm not presenting on that at the moment. I don't have the cost figures with me. Otherwise I would gladly have shared it, because there is definitely value in that.
Yeah. Okay, thank you very much. Wonderful presentation, and we thank you.
Thank you so much.
Yeah, thank you so much. Okay, I call on the next speaker now. The title of the work is Radical Innovation and Taboo: How to Encourage the Acceptance of New Menstrual Products in South Africa Through Behavioral Design. And the authors are Pierre Findlay and Angus Donald Campbell.
Hi, yes, I'm here.
Please note that you have 12 minutes to present your work and 3 minutes for questions. You can start.
Thank you. I just can't click the share button at the moment to share my screen. I'm not sure.
The technician will help you through now.
I'm sorry?
You'll be helped now.
I'll be helped now.
Try again.
Perfect, thank you, yes. Is it visible?
Yeah, you can see it clearly.
Fantastic. All right, good afternoon or good morning. So my name's Pierre Findlay, and I'm a design graduate from the University of Johannesburg from the Department of Industrial Design, and co-authored this paper with Angus Donald Campbell, which was based on my master's dissertation. And my title is Radical Innovation and Taboo: How to Encourage the Acceptance of a New Menstrual Product in South Africa Through Behavioral Design. Now, my research into the menstrual health realm started during my honours year, where I undertook a project to design a new menstrual product. And the outcome of that can be seen here, which is a reusable period pad made from medical grade silicone, and it has a surface of cavities that actually retain fluid, so it would retain menstrual fluid, and you can then wash it out with water, dry it, and reuse it immediately. So the obvious benefits of this were that it is more environmentally sustainable as it creates no waste. It's more affordable. And another consideration was to accommodate the value around virginity that exists within South Africa. So it had to be a product that was worn externally. So the project was successful, and the product was patented, but we did receive some pushback because it was a radical product, a radical innovation within a taboo field. So the problem with radical innovations are that they fall outside of the frame of reference of users. And we as people like things that have been trialed and appear safe and familiar, and also that align with our social norms and our social contexts. And both of those elements rely or fall into the context we find ourselves and the culture that we're part of. Then similarly, the product is also a taboo. Of course, menstruation is something that isn't spoken about a lot. Periods are expected to be kept a secret. And the rules around how this is done varies again depending on the context and the culture that one is part of. So a new menstrual product is quite difficult to introduce into the market, especially when everyone is denying that they even make use of them. So looking again at the title of this paper, it's looking at how to encourage the acceptance of a new menstrual product in our context through behavioral design. So we really looked at what are the behaviors around menstruation and the perceptions around it, and how can one go about shifting those. And the research framework that we made use of is something called the activity theory, which you can view here, this triangle. And essentially that is an unpacking of human behavior, both on an individual and a social level. So it takes into account both the individual and the context. I'll go through briefly these elements that play a role within it, starting with the subject, which would be the individual in question, in this case, a person that menstruates. And they have an object or an objective, a motive, and they fulfill this action with the use of a tool that enables them to do that. Which seems rather simple, but then what comes into play are all these other actors within the system that influence the outcome of this action. And these are things like rules, which are social norms, community, which is the social context one finds oneself in, and division of labor, which is in this case things like other menstrual product companies and what they say about how one should behave. So again, it's shown that action is reliant both on one's context and one's culture. So in my project, looking at appropriate technology was not only looking at the practical, material, and physical abilities or availabilities in a context, but also what the culture was, what the cultural norms are, and taking those into account. So again, looking at the activity system and all of these elements that influence one's behavior, within the research, each of these elements were unpacked through in-depth literature reviews and interviews. And the outcome showed something very interesting. The outcome were these three themes that emerged that really influence people's behavior around menstruation that can be generalized. So the first one is that it's viewed as something really unclean. It is something that is contaminating and it's an impurity. It makes you impure. The second thing is, of course, this rule of silence. Everyone has to pretend that it's something that doesn't exist. You have to deny and hide it at all costs, which also obviously limits communication and education around menstruation. And the third one is rather interesting. It's that it has a sudden, strong link to sexuality. That, there's practices such as virginity testing that start being conducted on the onset of menstruation, and you're suddenly viewed as a woman, and are started to be sexualized. So these are the three themes that we needed to influence behavior around in order to introduce this new menstrual product. And then I'll briefly go through the outcome of this project, which was a guide, a practical design guide, we called it a honing guide, that could be applied to, as an iteration of the existing product. To guide the iteration of the existing product. And an important outcome of all of the research was that if you want to create change somewhere, you really need to carefully balance continuity, so keeping things the same, and then development, moving something in a certain direction. And so what we did, we used existing design methods and plotted them along this graph. And the first one being appropriate technology, which in this case looked at the context that you were introducing a product into and took into account the culture and the cultural norms while designing a product. So, for example, this product was external because there was a value around virginity. So instead of just ignoring that, you take it into account within your design and immediately generate more acceptance. Then moving along, I'll quickly go over the others. Designing for affordances really has to do with the look of a product, and it needs to look familiar. It doesn't need to look, strange, and this is something I've never used before. So from a visual element, you want to align your design with things and products that are already being used. Then designing of meaning, this is quite an interesting one. It's got to do with the connotation of a product. So if you look at disposable pads, for example, they are sending a message of this is something dirty, this is something you need to throw away. And simply by making the product reusable, it already changes the narrative around menstruation and pushes it in a direction of accepting one's own body. And embracing it as something, natural and normal that happens to every female. And then the last one is mindful design, which is really tapping into more conscious consumer behavior. This can be done through things such as campaigns that perhaps encourage more education around menstruation. That would be an example. So that's a more conscious lead into change. And after applying this, I'll briefly show you the outcome of the implementation in the design iteration. So here's just an image of the prototype of what the packaging would look like. It shares far more information about what the product is. The branding is a little bit more open. It hopes to be quite approachable. It stops using euphemistic language. It's more direct, we call it a period pad instead of like an intimate hygiene product or something vague like that. Inside you will then get an information booklet that unpacks what menstruation is, how it works, what you can expect around it, what are the symptoms. It's supposed to take the scariness of it away as well. And then the product was refined to look a little bit softer, hopefully more approachable. This is a rough prototype, and again, still easy to clean. And then we also worked on sort of more conscious campaigns that could go out, again, breaking the silence around menstruation and asking for more education on it. And the great thing was when we went back for user feedback, it was very positive, quite a change from what the product was in my honours year, and a lot of people claimed they would be interested and like to try something like this. So yes, thank you very much. That was just a brief summary of the paper that I wrote. Thank you.
Wonderful. I don't know the comment to make in this area, but actually, yeah, I find it very interesting. I just want to know, you are the specific person working on it, and are you also involved with some medical people Because if we want to, I want to know about hygiene aspects of it, the medical stuff, apart from just getting material that you put together. Have you considered how to make it very on the medical aspect? Is just what I want.
Yes. Yes, yeah, no problem. So I must say at the moment the project is on hold. I think we would need more funding if we were to take it forward at the moment. The interesting thing is this product is actually based off of a product that is inserted called a menstrual cup that is becoming more and more popular now. I actually saw one in Pick and Pay yesterday, which impressed me. And that's made from medical grade silicone and is used, it's a cup that's inserted and it collects menstrual fluid, and then you also just empty it and rinse it out. And yes, I have looked into what the requirements are, well, you know, basing it off of the cup, what tests those need to go through and what materials that makes use of, which I would then align myself with. And yeah, of course, I mean, this hasn't gone into practice yet, but it would definitely need quite a bit of certification before it enters the market.
Yeah.
Yeah, if that answers your question.
Is there nobody that wants to ask any question? Area? It's, I think I am satisfied. The area I wanted to know was which material are you using for this? And there is a particular people that are designing the specific material that to be used in it, and be able to answer that. So thank you very much, Ms. Findlay.
Yes, thank you very much.
I think your project is very, very interesting. Very interesting.
Thank you. All right, thank you for having me.
Thank you. Now I call on the next presenter. I think we couldn't find them the last time, but let's see if they are available now. The title of that work is The Significance of Maturity Models, Application in Manufacturing Towards the Adaptation of Industry. A review. The authors are Meshach Masibuko, Lagwe Katibu, Abi Mashamba. Anyone of them around? They are not around. So I'll call on another paper while we still wait for them. The next paper is the development of a modular pickup and place robot, automated guided vehicle. Authors are Modestus Oku, Oluwatoyin Oyejide. I think I've seen Oluwatoyin Oyejide. All of them are here.
Yeah.
Okay, yeah. So we have made you a presenter. Can you upload your presentation?
Thank you. I'm trying to share the screen now.
Sure. Mr. Oku, you have 12 minutes to present your work, 3 minutes for questions.
Okay.
Just start up now.
All right, please, can you see the screen?
Sure, I see it now.
Okay, thank you. So the title of the work is Development of a Lightweight Material Handling Automated Guided Vehicle. Yeah, and the content we have here, introduction objective, material for developing the AGV system, design consideration, component parts of the robot and others. Yeah. So introduction. So as you can see on the right-hand side of the screen, yeah, we have the design of the AGV system. Yeah, the research describes the pattern of navigation of of a robot. Yeah, using via a line following robots here, and the motivation actually is because of the previous work we did that is based on navigation of products, that's moving items from source to destinations here, real items from one factory location to another. And with this, we decided to develop something, interesting like this here, using local materials. So the system, the unmanned ground vehicle, is developed to move items from
Hello, we can't hear you. Hello, Mr. Oku.
magnetic switch, the batteries, the Arduino microcontroller, and other components, as we can see. Of light as possible to consider the source to destination points and battery management, and possibly material with that is very that's of lightweight. Then here we have the mechanical components of the material, and majorly in terms of classification, yeah, we'll consider the chassis, the steering system, and the lifting mechanism, yeah, that we have here. For the chassis, we used a light local wooden material, yeah, because of the availability of the material at no cost, yeah, because we actually got the material for free, and also very lightweight. And for the lifting mechanism too, we also used a wooden material, which is incorporated on the AGV system to assist in moving items from place to place. Then the steering system, we consider a 3-tier system. Yeah, the front and the 2 rear wheels. So the front wheel can navigate at 360 degree, while the rear wheel follows here. So then after then is the electrical components. We considered here the DC motor, the battery, the microcontroller, the motor driver, regulator, infrared sensor, and other components here. So this is just like the procedures here we followed in developing the system. And we can see on the fourth, pictorial view here is what the AGV system looks like. Yeah, so, and the path to follow is also shown here during navigation from source to destination. Then the AGV path planning, yeah, we tried as much as possible to ensure, because we actually tested the robots thereafter, but we tried as much as possible to design, achieve such using the IR sensors, and the system was programmed in such a way that the facility layout background is white, and the path program for the robots, was actually mapped black here, because it's line following, and it has to follow a black line here in the process. And also, the sensor tries as much as possible to detect the black line and follow the path suits here. So the idea is that the microcontroller uses the ATM Mega 328, is of low power with C CMOS 8-bit microcontroller based on AVR architecture. We use that because it's inexpensive and easy to program using the Arduino software, and also at a very good operating voltage here. So, but another aspect is, apart from developing the system, it became very important to analyze the robot developed. Yeah, because we cannot say, just like someone who really wants to move an item from place to place, if the person is not strong enough, he might not be able to achieve that within a record time. So after developing the system, we tried as much as possible to, test the robots in terms of total intelligence system of the robots here. So to know exactly, the performance strength of the robots here. So we considered the perception of the robot, the task in terms of task accomplishments. We try to look at how the robots can navigate in terms of moving items, then the pick and drop system accuracy, then the pattern of navigation to battery efficiency and possibility of avoiding obstacle during, navigation. So what we did is we used the creative algorithm method to, test the strength of the developed robots. Yeah, and here under the system intelligence, based on the features I earlier mentioned, yeah, we performed 4 tests. Yeah, the first tests, second, third, and fourth. And at the end, we tried to check the average. Then we came up with, by looking at the semantic attributes here, it fell into, after the testing, it fell into the 4th category, which is within the range of 0.66 to 0.67. We actually obtained 66% efficient system, which falls into the 4th category. So we can say that the robot developed is it's good enough here. So in terms of rating, yeah. Then thereafter, okay, yeah, so that's just what we did here. But so far, we developed just a modular system, and we are looking at the possibility of scaling up the developed robots here. And we're actually coming up with a more interesting system, because the first actually we developed happened to be like a trial version. And we are looking at the possibility of developing a more interesting system that will, possibly navigate and solve day-to-day problem, be it like picking an item within the hospital facility or moving an item in a workshop. And that's exactly the next level we are looking at. And the future, like for our future research, we're looking at the scaling up of robots, like I earlier mentioned, and the possibility of interacting, having a kind of swarm systems where about 4 or 5 robots can come together, picking item and placing item without collision. So that's the next idea we're looking at. And we're also looking at linking up this research with supply chain in such a way that we can look at the robots at the inbound, the in-process and outbound level. At the inbound, like moving a product into a factory, there we plan to use the UAV system or man area vehicle that will move item in terms of raw material into a factory. Then we can now look at the possibility of developing more interesting robots that can really communicate and interact within a factory system. Then at the end of the day, look at the possibility of synchronizing both the UAV and the HV system together under a complex, in a complex environment by looking at the pattern of interaction of these robots here. So that's the next level we are really looking at. So we're linking it up with supply chain, both at the inbound, the in-process, and outbound level. So that's just what we have really done. Thank you very much for listening.
Wonderful.
Thank you.
Wonderful. We have a question for you from Dr. Danta. It says, great presentation. Please kindly identify the materials that were locally sourced according to slide number 5. I also have similar question. Identify the local content in terms of material.
Yes, the content in terms of material happens to be the material for the chassis. Yeah, it's a wooden material. Yeah, even the casing too, we use the wooden material for it. And also the acrylic, which is like the pick and drop system, we also use wooden material for it. And we obtained it at no cost here.
Okay. So when you were referring to the lightweight material, which material were you pointing to specifically?
Yes, the chassis. Yeah, that's the wooden material used here, the casing, and also the pick and drop system. That's the what's it called, the grabber.
Okay. I then want to know that, okay, in this system that you have created, there is no metal that is used at all.
No, not at all. We used wood material through, yeah, just as a demonstration to see what this can really do. Everything happens to be only material source look, yeah. Apart from the materials really incorporated to make up the system, like the Arduino microcontroller, the servo motors, and other parts. Yeah, these are just, you know, parts that we really sourced for. Yeah, but in terms of all the material, the parts that we use for the material, we use locally made materials. But if we plan to develop a, we look at
Hello? Yeah. The lifting mechanism, like you said,
yes, ma'am.
is made up of wood.
Yes, wood.
Okay, what is the maximum load that this can carry?
The maximum, yeah, the maximum load it can really carry. It's based on we actually use what's it called? We have to look at a factor of safety in terms of.
Can't hear
the system that we developed here.
So you didn't check which weight can it carry?
Yeah, we just developed it to carry very light materials at this level. But maybe while looking at expansion of the material, we can start considering the possibility of lifting very heavy loads and, you know, calculating every, yes.
Calculating maybe the strength to weight ratio and all that.
Yes,
you have to consider all those terminology. Thank you for a new, can I say a new concept in this robotic, because the robot is basically on the floor there, I can see. It's not that high.
Yes, a very small robot.
It's very small. Actually, it's a good innovation.
Yes,
Thank you.
Thank you very much.
I'm encouraged to go further.
Thank you very much, ma'am. Thank you.
Thank you for the presentation. Here's an outcome on another presenter. We have called them before and they were not available. So is Mishek Masiboku. It's Mishek Masiboku, Nagugi Katibu, and Abel Masham Ba. They are not around. Okay. Since they are not around, that brings the first session in room B to an end. The other people are after lunch. So that brings this session to an end. We will continue by 2 o'clock. You can then use that time to get your own lunch and then be back in this room by 2 p.m. where we have also 6 presenters. Thank you for your time.